Question 19 from the 2022 National 5 Physics Examination from the SQA. Which of the following is a longitudinal wave? Is it sound, radio, ultraviolet, infrared and light? Well, we can see that 4 out of those waves are members of the electromagnetic spectrum, and sound is not one, and sound needs a medium to travel through. All the rest of those waves, radio, ultraviolet, infrared and light, can travel through empty space. In fact, the longitudinal wave there is sound. That's the sound wave, so the answer to that is A. Just a wee recap on that one. The longitudinal wave is one which needs a medium to go through. You can see the particles all crunching up and then spreading out again as the wave pulses through the medium. That's a longitudinal wave, and that's the sort of wave that describes sound. Radio, ultraviolet, infrared and lights, they can be considered as a transverse wave. And a transverse wave, the direction of the wave is travelling, the particle movement is in fact at right angles to the movement. Compare that with a longitudinal wave, where the direction of the wave is the same direction as the movement of the particles. The particles go back and forth. So answer to question 19, what's a longitudinal wave? Sound's a longitudinal wave. Question 20. A radio station transmits radio signals with a frequency of 3.0 MHz to 6.0 MHz. The maximum wavelength of the radio signals transmitted is, and you're given your 5 options. Well, we know where to get the equation from. It's the famous wave equation. We can put down here V equals F lambda. And we can rearrange to find out what lambda is, because lambda is going to be equal to the wave speed divided by the frequency. And we also know that the wave speed is 3 times 10 to the power 8. Now we can do those two calculations separately and compare them to be really quick. We can say that in terms of lambda equal to V divided by frequency, we'll take a look at the 3 megahertz wave. That's equal to 3 times 10 to the power 8, that's the speed of light. And we're going to divide that by a frequency of 3 megahertz. Now 3 megahertz is 3 times 10 to the power 6. So if we do that in our calculators, we get 1 times 10 to the power 2, which is really the same as 100 meters. So take a note of that. That's for a frequency of 3 megahertz. So we'll put that there. That's the 3 megahertz frequency, giving you a wavelength of 100 meters. Then you can do the same calculation again. Lambda equals V over F equals the speed of light, 3 times 10 to the power 8. And we're going to divide this time by 6 times 10 to the power 6. That's what a megahertz is. And that's going to give us 0.5 times 10 to the power 2, which is going to give us in fact 50 meters, because 10 to the power 2 is 100, 100 times 0.5 is 50. So that's for the 6 megahertz one. So you can see that the radio station emits the longest wavelength in the 3 megahertz range here. So it says the maximum wavelength of the radio station transmitted is, and the maximum wavelength is going to be 100 meters. And the answer to that is going to be D. So 100 meters is the maximum wavelength. Question 21. A student draws a diagram to show the bands of the electromagnetic spectrum in order of increasing wavelength. Now the diagram is not correct, and we're asked to find which 2 bands of the electromagnetic spectrum are in the wrong position. Well, I always usually focus on the visible light first of all. So if you take a look at the visible light, that's that part there, you know that to the long wavelength side of it, there should be infrared, and to the small wavelength side of it, there should be ultraviolet. So just looking at that diagram, I can see that the 2 wavelengths that are not in the right place are infrared and ultraviolet. And we just need to swap them over. Infrared always appears in the long wavelength side, and ultraviolet is always in the shorter wavelength side. So there you go, and that's put in the correct order for you. So we're looking for ultraviolet and infrared, and we go down the list right now. We've got the one which is going to be the wrong one there. Ultraviolet and infrared is going to be answer C. So that will be the answer to that question, answer C. Another way to think of it is visible light. We have got the spectrum being violet, indigo, blue, green, yellow, orange and red, and that's in the increasing wavelength. Remember, red's longer wavelength than the violet light. So you must have infrared in that side, and you must have ultraviolet in that side. So that's the two waves which were in the wrong position. Answer 21C.